Hey guys, this is going to be the 3.5 derivatives of trig functions. It's pretty short. I'll try not to drag it out by talking too much. We are going to derive one or two of these, and you should understand how we're getting them, but it is also just flat out important that you memorize them. You must know these. You must know that the derivative of sine is cosine. You must know that the derivative of cosine is negative sine. This needs to be something that you just can't forget, kind of like low d high minus high d low over low squared. All right, so let's look at the first one that we're going to kind of talk about. We're going to prove the derivative of sine. And in order to do that, we need a few things. We need just to understand a few things that we're going to use in the derivation. All right, first, you know this one. The limit as x approaches 0 of sine x over x is 1. That's something we proved maybe a chapter ago. You should remember that. Now let's look at this one. Investigate the limit as x approaches 0 of cosine x minus 1 over x. Well, let's look at the graph of that. So I'll come over here. This is the graph of cosine x minus 1 over x. And as it approaches 0, do you agree that it looks like the limit approaches 0? As your x value approaches 0, it looks like the y value also approaches 0. Well, let's prove that. Oops, I did not mean to do that. Let's prove that algebraically here. Okay, so if we were to prove that algebraically, let's start with the limit as x approaches 0 of cosine x minus 1 over x. All right, so it gives us a hint here what we need to do. Let's multiply top and bottom by cosine x plus 1. What does that give us on the top? Well, it gives us the cosine squared x minus 1, because this is a difference of two squares now, and it would have broken up like that, over x times cosine x plus 1. Looks funny. Okay. Well, do you remember from trig the identity, the Pythagorean identity that says sine squared x plus cosine squared x equals 1? Well, does it therefore make sense that if you rearrange this and you have cosine x squared minus 1, that is going to equal negative sine squared x? Well, let's use that information here. And then right here, we're going to trade this out. So instead of cosine squared x, we're going to have negative sine squared x. Okay, so now we have the limit as x approaches 0 of negative sine squared x over x times cosine x plus 1. Well, when we're doing limits, it's possible, if you recall, to break the limit up into multiple pieces and kind of take the limit of them individually. So I'm going to do that. I'm going to have the limit as x approaches 0 of negative 1. That's my negative sign here. And then I'm going to have the limit as, I keep wanting to say h approaches 0, of x approaches 0 of sine x. Nope, I just want to do sine x. I want to break my sine x up. Of sine x over x, so that's one of the signs here, over this x, times the limit as x approaches 0 of sine x over cosine x plus 1. All right, so take a second if you need to and convince yourself that this limit times this limit times this limit is the same thing as we started with. Now let's actually get our answer. So the limit as x approaches 0 of negative 1 is just negative 1. The limit as x approaches 0 of sine x over x, well, that was what we reminded ourselves up here. That is 1. Now the limit as x approaches 0 of sine x over cosine x plus 1. Let's just put the 0 in for x and see what we get. We get sine of 0 over the cosine of 0 plus 1. Well, the sine of 0 is 0. The cosine of 0 is 1. So what do we get? We get negative 1 times 1 times 0 over 2. Well, that 0 over 2 is nothing but a 0, so our answer is 0. All right, so the limit as x approaches 0 of cosine x minus 1 over x is 0. And maybe you hear a cat in the background. My cat is banging on the window. All right, so let's look at example 3. Find the derivative of sine x using the limit definition of the derivative. All right, so we have, okay, we need to use the old-fashioned limit definition of derivative. So what we'll have is f prime of x equals the limit as h approaches 0 of, maybe you remember that, I'm going to write it out the long way, f of a plus h minus f of a, or that could be an x, over h. So when we use that in with our sine x, we have f prime of x equals the limit as h approaches 0 of sine x plus h. I'm using x's instead of a's because I think it makes more sense. Minus sine x all over h. That's not an h. I said h and wrote x. H. Okay. So the next thing we need to do is use some trig identities that quite certain no one remembers. So I'm just going to tell you. Sine x plus h. There is a trig identity that says the sine of a plus b is equal to the sine of a times the cosine of b plus the, what happened there? Plus the cosine of a times the sine of b. Maybe you remember that. I'd be surprised though. So let's just use that information here and substitute. So we get the sine of a times cosine of b plus cosine a times sine b. Yes, I like my parentheses, minus sine x all over h. And now instead of a's and b's, I should have obviously written x's and h's. So I'm going to go back and change that. There, that's better. Okay, so next what do we do? Well, we have a sine x here. We have let's see, thinking and writing at the same time. All right, let me write it and then I'll discuss what I did. Okay, so what I did was I dropped the parentheses. I have sine x cosine h plus cosine x times sine h minus sine x. I dropped the parentheses. That's fine, nothing changes. And I rearranged the equation so that I could take this sine x right here and this sine x right here out in front. Okay, so I removed the sine x here. I have cosine h. Took the sine x from here. I have a minus 1. Now I still have plus cosine x times sine h. This did not change right here. And then all over h. Okay, and then the next thing I need to do, I'm going to run out of room here. Cosine h minus 1 over h plus, now do you remember that you can separate your limits like this? Not only can you separate them multiplying like we did in the previous problem, but you can separate them in this fashion, over h. Okay, so let's look at what we have here. If we separate it even a little bit more, I have the limit as h approaches 0 of sine x times cosine h minus 1 over h Does that look familiar? Because that is exactly what we just took the derivative of on the previous problem. And then we have plus the limit as h approaches 0 of cosine x times sine h over h. Okay, I'm running out of room. I hate to go to the next page for this. I'll just do it in a different color and kind of squish it in. All right, so what do I have here? Well, the limit as h goes to 0 of sine x is simply sine x. There's no h in there. Times the cosine h minus 1 over h. What was that? Well, we just found that a minute ago, and that was 0. Plus the limit of the cosine x. Well, again, we just plug 0 in for h, and there is no h, so we get the same thing we have, cosine x, times sine h over h. Well, the limit as h approaches 0, sine h over h is 1. So, what do we have? We are left with the cosine of x. Therefore, if I can come up here, therefore, if you start with the function sine x, you are able to get the derivative is equal to cosine x. Pause. Oh, wait. Okay, I'm back. I hope that break worked. I had to stop and say something to my family. All right, let's go to the next page here. Find the derivative of tangent x using the quotient rule and the derivatives of sine and cosine. This is much quicker than the previous one. So, what do we want to find? We want to find the derivative of this. Well, since we don't know it yet, let's put it into something that we do know. We do know that the tangent is the same thing as the sine over the cosine. Now, this is a quotient rule, sine divided by cosine. So let's try just taking the derivative using the quotient rule and see if we have all the information we need. Because right now, what do we have in our tool belt? We just proved the derivative of sine, and hopefully you've looked back at the derivative of cosine here. Derivative of cosine is negative sine. So we're going to use both of those in our proof here. All right, quotient rule, low d high minus high d low over low squared. Well, low is just cosine x times the derivative of sine x, which is cosine x, minus high d low over low squared. Okay, what does this give us? This gives us cosine squared x plus sine squared x over cosine squared x. So what does that give us? Well, do you remember that Pythagorean trig identity that says cosine squared x plus sine squared x equals 1? All right, well, let's use that. 1 is a lot more simple than all that mess, so we'll say 1 over the cosine squared x. Well, what is the cosine squared x when it's on the denominator like that? So it's a reciprocal function. That's the same thing as 1 over cosine x times 1 over cosine x. Hopefully you're looking at this going, oh, I remember what that is, and it is the secant. So when it's 1 over that one times 1 over that, you get secant squared. So the derivative of tangent x is secant squared x. Okay, those are the last ones we're going to prove. Again, you must memorize these. Must. There's no getting around it. Don't put it off. Just go ahead and do it. Make some flashcards, put it in your phone. I don't care. Okay, so let's do some problems. Now we have the power rule, the product rule, the quotient rule, and the derivatives of all 6 trig functions. So we can do quite a lot of problems at this point in time. Let's see. Find the derivative of each function. Before you begin, state which rules you're going to have to use. The product rule seems to be the rule that people forget to use. Try not to be one of those people. I very much agree with this. When I graded your test yesterday, the product rule was the one that people just forgot and just would say that the derivative is 1 times the other, and you can't do that. You have to use the product rule. You'll get to where you can't forget it, but for now maybe we just need more practice. All right, so this is one function times another function, u times v. So it is imperative that we use the product rule. What does the product rule say? Well, it says the first one times the derivative of the second one plus the second one times the derivative of the first one. Guess what? That's the answer. That's it. We're done. Happy? I hope so. All right. This f of x equals cosine x over x is a quotient rule. I should have actually written it right here, so I'm going to go back. Product rule. All right. Product rule, quotient rule. Quotient because it is divided. So what is the quotient rule? Low d high minus high d low over low squared. So we get f prime of x equals low d high minus high d low over low squared. We'll clean that up just a teeny bit and we're done with the problem. So we would have negative x times sine x minus cosine x all over x squared. That's our answer. Next problem. Square root of t equals 4 times secant t. Well, I'm going to rewrite the problem before I get started and say t to the 1/2 plus 4 secant t. So how do we take the derivative of that? G prime of t equals, okay, t to the 1/2 power, that's just a normal power rule. So this is going to be a power rule and a trig derivative. Okay, so we would have 1/2 t to the negative 1/2 plus 4 is a constant. It's basically 4 times secant t. You could use the product rule here, and when you went to take the derivative of 4, you'd get 0, so that part of it would go away. But if it just bothers you that you're not using the product rule when these are times, do it a couple times and prove to yourself that it's fine to just bring the 4 down front and then take the derivative of secant t. Well, what is the derivative of the secant? It is secant t tangent t. Secant t times tangent t. That's the answer. There's not even any really reason to clean that up, so we're just going to leave it like that. Let's look at the next one. H of theta is equal to 5 secant theta plus tan theta. All right, so h prime of theta is equal to 5. Derivative of secant theta is secant theta tan theta plus, what is the derivative of tangent theta? It is secant squared theta, and you're done. They're very easy problems. It's just a matter that you're not going to have a note card on the test. You're going to have to memorize them. It is a must. All right, next problem. H of s equals 1 over s minus 10 cosecant s. So we get our derivative. Before I do that, let me rewrite this problem right here. So I have s to the negative 1 power minus 10 cosecant s. I don't like that, cosecant s. Okay, so the derivative is just going to be negative 1 s to the negative 2 power minus 10. What is the derivative of cosecant? It is cosecant cotangent. All right, clean this up just a little bit. It's not really even that necessary, but I will do it anyway. Oops, I messed that up. What is the derivative of cosecant? It is negative cosecant s cotangent s. Let's go back and look at that. Here we go. The derivative of cosecant is negative cosecant cotangent. There I am. Okay, so that makes this plus 10 cosecant s cotangent s. Okay, last one. What kind of rule are we going to have to use on this one? X times cotangent x. This is a product rule. All right, so we get y prime equals the first one times the derivative of the second one plus the second one times the derivative of the first one. Rewrite it just a little bit. And we're done. Yay! I hope I did that in record time. You guys get started memorizing those things and let me know if you need anything from me. Okay.